Assalamualaikum warahmatullahi wabarakatuh and hello everyone. In this video, we're going to discuss the face-to-face week 9 hour 1 tutorial. So for this hour, we are going to learn about the free radical substitutions regarding the mechanisms involved in alkane. A mixture of propane and bromine is exposed to sunlight. So 1A, they want you to write the reactions equations to show the formations of mono-substituted product. So please bear in mind that the mono-substituted product represent that only one substitution happen at a time. So the keyword here is the sunlight, and also given to you an alkane together with bromine. So alkane will undergo halogenation reactions when reacting with bromine. So we're going to write the reactions equations. To start with, we'll have the propane with 3 carbons, so CH3, CH2, CH3, react with the bromine as Br2, and then with the presence of sunlight UV, we're going to have the product. So since we are going to form the mono-substituted product, even though we have so many carbon on here, we are going to substitute only one Br at a time. So how do we know what kind of product are we going to form? We need to look at the classes of carbon in your propane. So at the first carbon on the far right, we're going to have the class of carbon of primary carbon. While for the second carbon, we're going to have the secondary carbon. As for the third one, we're going to have also primary carbon. So since we have two classes of carbon in here, means we're going to have a combinations of two products. So our first product going to be CH3, CH2, CH2. Attached to this CH2 is the Br. Since we are going to substitute one of the Br from with the presence of UV, and also our second product, the mixture of this product gonna be CH3, CH attached to the central C, we're gonna put Br, and also CH3. So these are the two mixtures of product that we are going to form from this propane. So between these two, which of those will be the major and the minor? We're going to look at the stability of the carbon. So this carbon at the first product going to have a primary carbon because it attached to one alkyl group, while this carbon that bearing the Br going to have two alkyl group attached to it. So the first one gonna be the minor product, while the second one gonna be the major product. Now we need to state the type of reactions. So how do we determine the type of reactions for these particular reactions? Look at our reactants. We have alkane, which is the saturated hydrocarbon that got only single bond. So once they react with the Br2 with the presence of UV, we could see that one of the H being swapped with the Br. So it indicates that we're going to have a substitutions reactions. So we've already learned about this substitution reaction. We have 3 types of substitutions. It's either free radical, electrophilic aromatic substitutions, and also nucleophilic substitutions. So if we look at the species given, we have Br2 and they are non-polar compound. So with the presence of UV, they are going to cleave the bonds symmetrically. In other words, they are going to have a homolytic cleavage. So from the homolytic cleavage, we know that we are going to form species of free radical. So the type of reactions involved in these reactions is free radical substitutions. Moving on to the next part, we need to illustrate the mechanism for the formations of product. So in alkane, there's only one mechanism that you need to know, which is the free radical substitutions. So for this mechanism, we have 3 steps altogether. The first one is initiations, where we are going to form a radical. Second one followed by propagations, where the compound going to propagate themselves. So during this propagation step, we're going to form new radical, and also we need to expect chain reactions to happen, means the repetitions of forming the radical being formed in the initiations part. And lastly is the terminations, where we are going to terminate all the free radicals in order for the reactions to stop. we're going to start with the first step called ionization. So ionization is where we are going to form a radical. So this radical comes from the Br. So we're going to start with this Br2. We need to show the bond between the Br because we're going to show the mechanism, the curly arrow. So with the presence of UV, this single bond will break symmetrically to give you equal parts of Br radical. So we're going to get Br with one unpaired electron, which we call them as a radical. So this is the first step of this mechanism. Next, we're going to proceed with the step 2. Step 2 is known as propagations. During these steps, we're gonna form a new radical. So these new radicals gonna comes from the propane. So we know already the radical formed at the first step cannot remain silent. So they are very reactive. They're gonna attack another reactants that have around them. So we're gonna react this Br radical with our propane. Since we're gonna have combinations of product which include the major and minor, usually for the mechanism, we're gonna focus on the major product. So the major product will involve the carbon at the center. So we're gonna show the bonding between C and H at the carbon center. So we're gonna have CH here, and attached to it we have H, and we have CH3 down here. So basically, this single bond between C and H, because they are non-polar bond, they are going to break symmetrically. One unpaired electron will go to the C and another one will go to the H. But instead of going to H, we are going to give it here because we want to combine it together with the Br radical. So they are going to immediately form a product. So from these reactions, we know that we are going to form a new radical of this propane, so propyl, so CH. At the moment we have radical in here together with the HBr that combined to form the HBr bond. So we could see this is our new free radical formed. And also at these steps, we're gonna make the reaction to repeat itself. So once we have formed this new radical cannot stay silent. They are going to attack another species. So we need to be reminded that there's no only one molecules in each reactions. We have abundance of them. So this new radical, the CH3, I will rearrange them like this. So we have CH and CH3 to make the radical faces one another. Gonna attack the Br bond. So again, this bond will break symmetrically, and then this bond will attack to this radical, and this radical will combine. And lastly, to give you a chain reactions where we are going to form another Br radical. So this is where the repetitions will happen, and what will happen to the other radical that combine with Br, we're gonna get a new species of CH3, and we have here the Br. So we have formed another radical that we have formed earlier in step 1. And lastly, step number 3 is called as terminations. Termination steps involved all the radical to be eliminated. So means we have formed 2 radicals of Br and also CH3. Now we are going to combine between the same radicals. So we're going to have 2 products. And lastly, to combine one new radical and also another radical. So we're going to show this by using the curly arrow. So by having 2 radical of Br, we are going to form the Br bond like this. So we're gonna combine them together, and then they will form a new bond. Same goes to the CH3, CH3H, we have free radical here. They are going to attack the same radical. By showing the curly arrow means you show the mechanism. Without the curly arrow, it is not a mechanism. So we're going to get a new bond between C and C. So you must show the bonding. So we have CH, CH3, CH, CH3, H3. And lastly, we need to combine the last combinations between the CH, CH3 radical together with the Br radical. So we need to combine these two by using this half-headed arrow. Lastly, to give you product of CH3, CH, CH3 with Br attached to the central carbon. So that's it for question 1. Let's proceed to question 2. So we're gonna have these questions that tells you that the reactions between alkane with molecular formula C5H12 with chlorine in the presence of sunlight gives only one product. So I forgot to mention that this is only one product of C5H11Cl. Means that the structure that we need to emphasize only gives you one type of product, no combinations of product. So the question wants you to suggest the structure of C5H12 and write the reactions equations. So first we need to suggest the structure. Second one, we need to write the reactions equations. And lastly, to outline the mechanism for the formations of product. So when having alkane react with the presence of UV, then we are going to go for only free radical substitutions as the mechanism. But we have some conflict in here because in previous example, we have a combinations of product. But this time around, we want only one product. You need to be familiar with the term mono-substituted doesn't mean only one product. Mono-substituted product means you only substitute one at a time. But if we want only one product of mono-substituted product, means we want only one product, no mixture of product. Okay, since we have C5 as the longest chain, we're gonna do the chain isomer for this alkane to see how many classes of carbon that we can get from each alkane. So we'll start with the longest carbon. I'll use the skeletal structures. So we're gonna have 1, 2, 3, 4, and 5. If we look at this structure, let's have a look at the classes of carbon. So here we're going to have a primary carbon. Here we have secondary carbon, secondary carbon, secondary carbon, and primary carbon. Means that if we have more than one classes of carbon, we are going to have a mixture of product. So we cannot take this compound as our C5H12 that will give only one product of mono-substituted product. We're going to have a look at the chain isomer for this. We'll start with the 4 carbon as the longest chains. So we're going to have 1, 2, 3, and 4. And one of the carbon will become the branch like this. So we'll have a look at the classes of carbon. Here we have primary carbon. Here we got tertiary carbon, primary carbon, and secondary carbon, and lastly is the primary carbon. We have a mixture of primary, secondary, and tertiary, and basically this compound will give you a mixture of 3 products, so we cannot take this compound. Next, we're gonna make another chain isomer from this compound. We're gonna take only the longest chain of 3 carbons, so we have 1, 2, and 3, and then we're gonna have 2 branches at carbon number 2, 1 and 2. So altogether we have 5 carbon. So let's look at the classes of carbon. So we gonna have here as primary carbon, primary carbon, primary carbon and primary carbon. What about this one? This is quaternary carbon. Even though carbon got until quaternary carbon, but in order for you to do the substitutions, they'll go up to tertiary carbon based on the free radical species. Free radical stability starts from the methyl, primary, secondary, and lastly the tertiary, no quaternary. Means the only product that can be formed from this compound is from primary carbon. So the last compound here will give you only one monosubstituted product. So we'll take this compound to do our reactions. When writing the reactions equations, we need to take out all the possible products that we can form. But since this compound of our selections that got 2 branches at carbon number 2 will give you only one product, so we're going to have only one monosubstituted product. So this compound going to react with Cl2 with the presence of UV to give you only one product. So this Cl can be substituted at one of the hydrogen attached to this carbon. So we're going to substitute it with Cl. So initially, we have H here. We are going to substitute this H with the Cl by using free radical substitution. Next, we're going to do the mechanism for these reactions. In order for you to do the mechanism, you need to start with the general reactions as in our first sentence here. So the mechanism going to involve the 3 steps we have done earlier. So as for this first step, you need to write the first step, ionization. As for ionizations, we're going to take this Cl and Cl, and we're going to break this bond symmetrically to give 2 equal parts of Cl radical. Next, we'll proceed to the second step of propagations. So the propagations reactions takes place when the radical formed in step 1 attacks the compound, our alkane. So we're going to have Cl radical react with, so we have this 1, 2, 3, 4, 5, and as we need to show the bond between the H and also C. And then we're going to break this into equal part. One goes to the carbon, another one goes nearer to the Cl like this. Then we're going to get a product of HCl and also a new radical of 2, 3, 4, and we're going to have a radical here. Now we have formed this new radical. We are going to create a chain reactions where we are going to reproduce this Cl radical. So by rewrite the new radical formed from these steps, we're going to attack the Cl bond. Then this Cl bond will break symmetrically to give equal parts of Cl radical, and then the Cl radical will combine with the alkane radical to give a new product of haloalkane like this, plus the Cl radical. So we have regenerated the Cl radical. Next, moving on to the final steps called as termination. Terminations is a step where the radical will be eliminated. So we are going to combine all the radicals formed so that the reactions will stop. So we're going to combine between radical Cl and also radical Cl. You need to show the curly arrow because this is a mechanism. Then they will form Cl bond. And then we have combinations of alkyl radical. So 1, 2, 3, 4. Exactly the same. 1, 2, 3, 4. So how do we know how many carbons will be formed? So we're going to see here. So we have 1, 2, 3, 4, 5, 6. So make sure that you're going to combine all 6 carbons, because this got one unpaired electron each. So once they combine, they're going to get together. So we're going to have 1, 2, 3, 4, 5, 6. And then at carbon number 2 here, we have 2 branch. So we're going to write the 2 branch, 1, 2. And then at carbon here, we have 2 branch. So this is going to be our final product. And lastly, we're going to combine between different radicals. So we'll have the first radical of alkane, and then react with the Cl radical. Oh, we forgot to show the mechanism. Don't forget to show the mechanism. So here we have the Cl radical. Show the curly arrow. Then only you will get the neutral compound. So we have 1, 2, 3, 4, 5, and then extra Cl. So that's all for face-to-face week 9 hour 1. Thank you for listening.